All right, we are now going to cover just slightly more advanced features. And so the other feature that I really want you to learn how to use is what's called Hue. So we are going to repeat 3 of those 4 plots, but now are you going to add this additional argument that most of the plotting functions take called Hue. So Hue is kind of strangely named, but the idea behind Hue is that you want to split your data into different classes. So this data set that we have here, you'll notice that there are 4 different data sets. So they're either 1, 2, 3, or 4. And so let's say we want to separate these when we plot these. That's a very common thing that you want to do. So now we have our X and our Y data, but we've added this additional Hue and we provided it with the name of the column that tells each row what data set it belongs to. And so plot.show, and so now you'll notice that how it works is that it's color coded all of the values based upon what data set they're from, and now we have this legend that's automatically included. So all of the points from the first data set are colored blue, etc. And kind of all of these different plotting functions will typically handle that. So now we see the line plots. So we see 4 different line plots for each data set. The regression plot as well. Now we have 4 different regression lines, 4 different colored scatter plots, and 4 different colored ranges for the line. You can also separate them into different graphs. So if we add this additional argument called col, so we're giving it also the name of the data set, and what this says is it says to separate these into the 4 different plots. So now instead of these all being on the same plot, they're now on all they're all on different plots. And so you can start to see that this data set kind of shows different distributions of data. So kind of scattered random distributions, distributions where they're not linear. So this data set isn't linear. And so this is problematic with fitting a linear function to it. You also have a data set that has a strong outlier. So this data point right here is an outlier, and so that skews the line away from the actual line of the data. And then the problem when you have large number of data points for one X value, but you only have 1 data point for the second value, and kind of the importance of this. So we've separated this into 4 different panels on the graph simply by using that call. And if we want to control kind of how it's distributed, that's also very easy. So you just add this call wrap equals 2, and so we're saying we want 2 panels per row before we wrap to the new column. And lo and behold, now it looks like this. So pretty. So the color choices, the hues, the color choices that are used for hues are also much nicer. So instead of having this like bright blue, bright red, bright green that Matplotlib uses, these are kind of colors that are considered aesthetically more pleasing. So very useful, and you can actually change kind of the palette that is used. There's a large number of palettes that are used that you can modify exact which one is used. So very easy way to change color schemes in very pretty ways. Finally, the last thing we're going to cover is kind of more complex data sets. So we're going to also read in the second data set called Iris. And so this lists information about petals for various species. So some sort of researcher measured the sepal length, I have no idea, sepal width, petal width for a bunch of different flowers. And so you might want to compare these, so we saw before how you could create, so let's just create something. Iris x equals, so if you wanted to plot, let's say, the sepal length versus the sepal width, and you wanted to separate on species, you can do that during this. And so now we can see this for the 3 different species that were within this. So we can see there's characteristic differences between species, comparing these measurements. But if you wanted to say, look at all of these 4 columns kind of together, pair plot, somehow an extra, is very useful for doing something like that. So you can see the length, the width, the petal length, and the petal width are all plotted. And so we can see the correlation between all of these measurements. So all possible comparisons are shown here. And then we also have a histogram on the identity axis that shows kind of the range of measurements. So you can see the petal lengths and petal widths are kind of bimodal, whereas these are kind of similar to a Gaussian or a modified Gaussian. So this is kind of the basics of Seaborn. So the examples that we go over will improve, hopefully, your ability to work with Seaborn. But it's a great library that I think you will most likely use throughout your career if you put in the time to kind of learn it.